Chapter 6. The Soil Pipe. 1. Soil pipe. By definition, any pipe that receives and conveys discharges of water closet, with or without the discharge coming from other fixture, to the house drain or house sewer, is called soil pipe. The word soil is affixed to pipe installation that carries human waste coming from water closet. Minus the waste coming from water closet, said installation is called waste pipe. Soil pipe installed vertically is called soil stack, and soil branch when installed horizontally. The National Plumbing Code on soil pipe provides 1. That at least one of the vertical stack in the plumbing system must extend full size through the roof for the following purposes: A. To ventilate and dispose of the sewer gas above the roof. B. To prevent siphoning of the water trap seal by force of suction. C. To prevent the possibility of back pressure, which may force the water seal off the fixture trap. 2. Any structure with a house drain installed must have at least one soil stack or stack vent extended full size above the roof, not less than 30 cm long, and should not be less than 75 mm or 3 inches diameter, or the size of the drain, whichever is smaller. Figure 6:1 shows the soil stack and soil branch. 3. As a general rule, vent stack must be extended and terminate through the roof of the building. When the roof is to be used other than protection from the element of weather, the vent stack should be extended no less than 2 meters above the roof. Figure 6:2 shows the vent stack extended through the roof. Installation requirements. To start with the soil pipe roughing in, the plan layout of the entire building installation must be prepared. This includes the location of fixtures, size of partitions, location of doors and windows, as well as the lowered ceiling that will conceal the soil and waste pipe branches. Building designers do not always use good judgment in indicating the location of soil pipe. Relocation of the soil or vent stack requires good judgment to accommodate the runs of associated vent, waste, and water pipes in a more practical way. To do this effectively, the plumber's knowledge of the layout must be complete and adequate. The location of electric outlet and boxes, cabinets, and other building necessities has to be set up. The soil pipe is generally placed before the mounting of partitions. Passing the soil pipe through any of this facility unit would be a reflection on the mechanical ability of the plumber and a fault that would be exceedingly hard to correct. The Plumbing Code on soil pipe installation provides that 1. The soil pipe shall be properly concealed or embedded in columns, walls, or partitions installed prior to the construction of the building. 2. The entire installation of building, such as location of fixture, thickness of partition, location of doors and windows, drop ceiling, electrical layout, and outlets, and their relation with each other shall be considered in the pre-planning stages prior to the roughing in work. 3. The soil branch that will directly receive waste from water closet shall be short and direct as practicable. 4. Soil pipe joints shall be tight and free from liquid or gas leak. Installation workmanship shall be strictly in accordance with the standard practice of the trade involved. 5. The soil pipe not embedded in concrete wall, columns or partitions shall be anchored rigidly by means of metal hangers. 6. The changes from vertical to horizontal directions shall be done using A. 1/4 bend, B. Long sweep 1/4 bend, C. 2/1/8 bend, or D. Combination of Y in 1/8 bend. 2. Size of the soil pipe. So far, there are no definite mathematical formula ever formulated to determine the size of soil pipe required for a particular installation. This is maybe because of the variable condition relative to its service. For instance, who can foretell how often one is going to use the plumbing fixture in a given time interval? Likewise, it would be more difficult for a plumber to ascertain how often and what time a plumbing fixture might be used, and to determine the size of the soil pipe on the basis of maximum discharge of all the fixture connected to it in a minute or an hour intervals would be nobody's guess. However, it would be certain that all fixture connected to the plumbing system would never be used or flushed simultaneously at one point in time, and it will be more impossible for the soil pipe to be carrying a maximum load from all fixture connected to it in one single moment. The fixture unit. In the absence of defined formula to use in finding the size of a soil pipe, the Uniform Plumbing Code Committee formulated the fixture unit data as the maximum waste discharge per minute interval of a particular fixture. Indeed, the code provides that the fixture unit be the standard values in determining the size of all plumbing installations. How to use the fixture unit values in Table 5:1, the following example is presented. Illustration 6:1. Determine the soil pipe diameter to serve 8 water closet, 3 shower bath, 4 urinals, 2 slop sink, and 3 wash basins. Solution. 1. Refer to Table 5:1 and find the fixture unit of 8 water closet times 6 units is equals to 48 units. 3 shower bath times 2 units is equals to 6 units. 4 urinals times 5 units is equals to 20 units. 2 slop sink times 3 units is equals to 6 units. 3 wash basins times 1 unit is equals to 3 units. Overall total of 83 units. 2. Refer to Table 5:2. Under total and stock, 83 unit is between 60 and 50 fixture unit, which could be served by a 100 mm or 4 inches pipe diameter. Comments. The total sum of the fixture unit as computed is 83. Even if this number would be increased by 5 times, the 100 mm pipe that could serve up to 500 units will be more than sufficient to serve the 83 units. 2. It seems that the 100 mm pipe is oversized to serve an 83 fixture units. However, since 83 units result of computation falls under the parameter of 100 mm pipe diameter, the provisions of the code must prevail. No choice, specify 100 mm pipe diameter. Illustration 2. Find the size of a soil stack to serve 2-unit water closet, 2 showers, 2 lavatories, and 1 residential sink. Solution 1. Find the total number of fixture unit using Table 5:1. 2 times 6 water closet is equals to 12 units. 2 times 2 shower bath is equals to 4 units. 2 times 1 wash basin is equals to 2 units. 1 times 2 kitchen sink is equals to 2 units. Total fixture unit of 20 units. 2. Refer to the table 5:2 under total in stack. The 20 fixture unit is within the limit of 50 mm or 2 inches pipe diameter. 3. The 38 mm or 1.5 inches diameter pipe could not be used because of the limitations set by the plumbing code, which states that no water closets shall discharge into the drain less than 75 mm or 3 inches diameter pipe. 4. Therefore, a 75 mm pipe diameter will be specified, not the 50 mm, even if it was the result of our computation. The plumbing controversy. At one time, the plumbing industry introduced radical changes from a traditional policy to one involving scientific principles for plumber's guide. One example is the old rule, which says 6 water closet, 6 wash basins, and 6 bathtubs were considered the maximum load that a 100 mm or 4 inches soil pipe could possibly accommodate. The rule further stipulated that in case one more water closet was added to the installation, a 125 mm or 5 inches soil pipe was required. In so short a time, the regulation was amended, increasing the allowable load from 6 to 10 water closet for a 100 mm pipe diameter. The new regulation triggered adverse opinion from the elders and conservative plumbers. The old plumbers, being traditionally minded, were not ready to accept the changes. They were not aware of the fact that the amendment was based on the result of extensive practical tests using a transparent plastic pipe supported by mathematical calculations and computers conducted by the Uniform Plumbing Code Committee. The experiment showed that a 100 mm diameter soil pipe could effectively serve up to 840 fixture unit or 140 water closets without overloading of the pipe. Transparent plastic pipe were used during the testing, and it was found that even if this water closet were used continuously at the same time, flushing at one point in time is statistically improbable. Moreover, the experiment revealed that proper ventilations of the fixture traps and careful installation of the pipe has contributed much to the efficiency of the system, rather than increasing the size of the pipe. Under certain conditions, more fixture may be added to the system without harm. Report of the Uniform Plumbing Code Committee, a publication issued jointly by the Department of Commerce and the Housing and Home Finance Agency, Washington, D.C. The experiment conducted by the Uniform Plumbing Code Committee revealed that 1. Instead of increasing the diameter of pipe, the ventilation of fixture traps should be looked into because it promotes efficiency of the entire plumbing installation. 2. The use of the right kind of fittings and proper installation, plus the strict observant of the prescribed slope of the pipe contributed primarily to the effectiveness of the drainage system. 3. Under a certain condition, more fixtures may be added to the installation without fear of being overtaxed. See report of the Uniform Plumbing Code Committee of 1949. 4. The experiment further revealed that the wet venting is safer under the certain condition. Stack venting for one or more story building has proven to be satisfactory. 5. Long drain, wet vented bathtub are safe, provided that the pipe is installed with a slope not greater than 2% or 2 centimeters fall per meter length. 3. The soil branch. The soil branch is a soil pipe installed horizontally with lateral or vertical connections that receive the discharge of water closet with or without additional plumbing fixtures. General condition in installing soil branch. 1. The soil branch being concealed in floors, partitions, or lowered ceiling should be accessibly provided with sufficient numbers of cleanout. 2. Cleanouts should be installed wherever changes of soil branch direction are made. 3. Cleanout should be the same in diameter as the soil branch. 4. Cleanout should be located at the farthest end of the branch away from the vertical soil pipe. 5. The use of short radius fitting on soil branch when making a change of direction, such as short sanitary T, 1/4 bend, and short L, should be avoided. Figure 6-3 shows soil branch. 6. A long radius fitting shall be used for a horizontal to horizontal or vertical to vertical change of direction. In some instances, the use of short radius fitting is only permitted on a vertical to horizontal changes of direction. Figure 6-4 shows the soil branch and cleanout. 7. Soil branch shall be graded properly and carefully aligned. Crooked joint should not be allowed. Figure 6-5 shows the change in direction of soil branch. 8. The efficiency of a horizontal waste installation depends upon the scouring or self-cleaning action for every discharge of waste. Soil branch having slope more than 2% fall has the tendency of separating the solid waste from the liquid. Water flows faster on high pitch, leaving the suspended materials at the bottom of the pipe. On the other hand, pipes with grade less than 2% is also susceptible to stoppage due to retarded flow. Figure 6-6 shows the slope of soil branch. 4. Size of the soil branch. The flow of waste inside the horizontal pipe, particularly the soil branch, is much different from those inside the vertical stack. As previously explained, the expected efficiency of a liquid flow inside the horizontal pipe depends upon the scouring action for every discharge. If this action could be attained in every pipe installation, stoppage problem could be avoided. Fixture groups differs in design, and to provide a soil branch of the size just to serve each type of fixture would be more difficult and impractical. Although scouring action is no longer a problem when 2% slope is followed, yet satisfactory result may be obtained if pipe of ample diameter is provided with a minimum and maximum fixture limit. How to determine the required size of a soil branch with the aid of table 5:1 and 5:2. The following example was presented. Illustration 3. What diameter of a soil branch is appropriate to serve a battery of 3 water closets? Figure 6 to 7 shows the battery of 3 water closets. Solution. 1. Find the total fixture unit of 3 water closet, referring to table 5:1. Water closet has 6 fixture unit, then multiply. 6 unit times 3 water closets is equals to 18 units. 2. Refer to table 5:2. Under the column 1 horizontal branch, a 75 mm diameter pipe could serve up to 20 fixture units. Thus, a 75 mm or 3 inches pipe should serve well the 18 units as computed. But the plumbing code on pipe size limitation states that not more than 2 water closets shall discharge into any 75 mm diameter horizontal soil branch, house sewer, or house drain. 3. The code must prevail. Specify a 100 mm diameter for soil branch, not 75 mm as computed. Illustration 4. What diameter of soil branch will be satisfactory to serve a battery of 25 water closet? Solution. 1. From table 5:1, the total fixture unit of 25 water closet is 25 times 6 units is equals to 150 fixture units. 2. Refer to table 5:2. Under one horizontal branch column, a 100 mm or 4 inches diameter soil branch could serve up to 160 fixture units. Therefore, 3. Specify a 100 mm diameter soil branch to serve the 25 water closets. Comments. 1. From the two illustrations just presented, it could be seen clearly that a 100 mm diameter pipe is required to serve 3 water closets, while it could satisfactorily serve 25 water closets. Much more, when the Plumbing Code Committee issued a report that a 100 mm pipe could effectively serve 840 fixture unit coming from a 140 water closet without the danger of overloading. 2. Would it not be confusing to see disproportional computation like this? It might be confusing, but since the fixture unit was formulated by the Uniform Plumbing Code Committee, the code must prevail. 3. However, considering the unending search for advancements in plumbing technology, this author believes that in the near future, this present fixture unit regulations will again get updating as what had happened when the committee amended the allowable fixture unit for several occasions. Noise and condensation. Noise is one among the serious problems of plumbing installation. It annoys the occupant. The water rushing down through the soil pipe within the wall creates various unwanted irritating noise. On the other hand, condensation causes the dripping of water inside the ceiling, the number one enemy of wood and other similar or related materials. Solution to this problem. 1. Soil pipe should not be in contact with plastered wall or ceiling because it will create sound that are magnified inside the room. Waste and soil pipe not embedded in concrete must be insulated. Hair felt or mineral wall material are packed around the waste or soil pipe as insulator to absorb noise. 2. Condensation may be overcome by applying a good quality anti-sweat covering material to the soil pipe installation. Prohibited fittings and connections. The National Plumbing Code of Fittings and Connections of Soil Pipe provides that A. Prohibited fitting 1. Double hub, double T, or double Y branch should not be permitted on soil pipe or horizontal lines. 2. The drilling and tapping of house drain, soil pipe, and waste or vent pipe, and the use of saddle hubs or bends are strictly prohibited. B. Dead-end fittings. Dead-end connections and any drainage installation should not be permitted. This portion of the plumbing system will only accumulate waste and sludge. Figure 6 to 8 shows the dead-end connection. End of chapter 6.